Welcome to MRS Bulletin's Materials News Podcast, providing breakthrough news and interviews with researchers on hot topics in materials research. My name is Sophia Chen. Michael Dickey, a chemical engineer at North Carolina State University, shows me a strange material that his team has discovered. In some ways, it's like a gel, which consists of polymers swollen with a solvent, like what you would find in a contact lens. But this gel differs from other gels in a key way.
Normally, when you add liquids to polymers, it makes them softer. Contact lenses, Jell-O, pretty much any kind of gel you can think of are kind of soft and squishy.
But this material is rigid, like a glassy polymer.
Glassy polymers just means that the polymer chains are stuck. They can't move.
Dickey's team says that these tough gels qualify as a new class of material, which combines the properties of glassy polymers with gels. They call the material glassy gels, and they have intriguing mechanical properties.
They've got the best properties of glassy polymers, which is, to say that they're stiff and they're strong. So they feel just like a lot of plastics that we have in our day-to-day lives, like imagine a plastic pen or a plastic cup or plastic bottle. But they also have some properties of gels, which is they contain liquid, and you can also stretch them a lot.
The glassy gels have two basic ingredients, the polymer and the solvent. Here they used a polymer known as polyacrylic acid.
It's the material used in baby diapers to absorb the urine.
For the solvent, they used a class of liquids known as ionic liquids. These are salts in liquid form. The ionic liquid they used is tributylmethylphosphonium dimethylphosphate, or PP for short.
People have estimated there could be up to 10 to the 18th. That means one with 18 different ionic liquids. You can add a carbon here, add a nitrogen there, and make them chemically different.
Then they cure the mixture of polymers and ionic liquid into a solid by shining UV light on it. Once cured, Dickey's team found that the glassy gel has many interesting properties. For example, they can stretch these glassy gels by more than 6 times its original length, and then it returns to its original shape and size upon heating.
We call that shape memory.
However, they have not rigorously studied how often this material can be deformed before failure. They also found that the material has self-healing properties.
If you take this material and you cut it in half, you can actually put it back together, and with a little bit of heat, the polymer chains will kind of go across the cut interface and will bind to each other.
The material is also adhesive.
If you take a glassy gel and you contact it with something, like a metal ball or another solid material, it sticks.
This differs from, say, superglue, which is no longer sticky upon curing. His team actually stumbled upon this material by accident. Dickey gives a lot of credit to his postdoc at the time, Meixiang Wang, for the discovery. Wang was working with ionic liquids to develop materials for wearable sensors. She was studying ionic liquids and making gels using ionic liquids when she created the first glassy gel.
She was exploring the parameter space of the amount of polymer and the amount of liquid, again, this ionic liquid. And then she found that she was able to make these materials with just incredible mechanical properties.
Dickey thinks these glassy gels would make good adhesives or could be used in 3D printing. Also, because it's full of ions, the material's conducting and might be useful for batteries. But ultimately, he's looking to the broader community to figure out how these materials could be useful.
Because we didn't set out to make a material to solve a particular problem, I view this as a little bit as like a solution looking for the right problem.
While other materials might exist with comparable toughness and stretchiness, Dickey says that the glassy gels offer an advantage because of its simple curing process.
It's very easy to make this. You just mix the materials together and shine light or apply heat, and that cures it.
This work was published in a recent issue of Nature. My name is Sophia Chen from the Materials Research Society. For more news, log on to the MRS Bulletin website at mrsbulletin.org and follow us on X @MRS Bulletin. Don't miss the next episode of MRS Bulletin Materials News. Subscribe now. Thank you for listening.